You're probably stuck at home with nothing to do. I'm lucky, I can come to my shop, no one's here and it's safe, and use the models I have of bridges and cranes to shoot some videos and tell you about trigonometry, torque, overturning moment, center of gravity, lots of stuff. So we'll start off with this crane. We got a, make believe this is a steel beam hanging from the hook. We have to raise it and put it in that little bucket there. So first I'm going to raise the boom. This is a windlass with a brake, which comes in video number 3. I want to get the beam directly over the bucket. That looks good. Then I'm going to lower it and see how accurate I can be. Bullseye, okay. Now let's make believe instead of a very lightweight piece of plywood, we've got a brick, 4.7 pound brick hanging from the hook. We have to put it here. And the train's going to go by in a minute making a lot of noise. Ignore it. So first I'm going to raise the boom. That's the hand signal for raising the boom. And here's the hand signal for raising the load. Boom, load. When you hear that clack, I know that the automatic brake will work. So I've got to lower the boom so that the brick will land over there. Probably just when the train comes by. So the boom's at 70 degrees now. Good. Okay. Well, I knew that was going to happen. You did too, probably. So the brick is 4.7 pounds. The crane body, which is this part, is 7 pounds. For now, we're going to forget about the boom. That'll come later. So, this is 4.7, this is 7. How come it tipped over? But it tipped over when the boom was at 65 degrees. I raised the boom. We're good. So, best way to think about this is make believe it's a seesaw or a balance beam. So, now I'm the only one here, so I have to run back and forth to adjust the camera, and unfortunately I don't have any editing software. Hopefully that'll change. So, garden variety balance beam. Each C-clamp weighs a pound. The distance from the pivot point is 20 inches on each side, so obviously it balances. You knew that. So if I put this here, well, you've all been on the seesaw, you know what's going to happen. So, how could I balance? Let's say I've got 2 pounds on this hook, and I have to balance it, and I've only got 1 clamp. 1 pound, so 1 pound balances 2 pounds. Well, you've been on the seesaw. You've got a heavy kit on one end and a light kit on the other end. The light kit has to go further away from the pivot to make it work. Just like this. Archimedes came up with the law of the lever, which basically says you take the weight and you multiply it by the distance from the pivot point, and that has to equal the same thing on the other side. So you've got 2 pounds, 10 inches away from the pivot. 2 times 10 is 20. And the other side you got 1 pound, 20 inches away, one time, same thing, 20 equals 20. Very simple, you knew that already. Now, what happens if we switch things around a bit? Let's see what that's going to look like. £2, £1. This is 10 inches away. This is 10 inches away. Tell you what, let's do it even better. Cut.